however, for this master's course, we're only focusing on bright censoring dataset. Okay. So I also have shared with you the YouTube video regarding this censoring in details. Okay. So in that video, okay, to summarize that video, the video also have mentioned how is the event. We call it as a censoring event, and also an if an event occur in your data, right? And then the video also explained about the left censoring, which we also not discuss in detail. Okay, so the left censoring meanings that you want to know the information before of a patient or of an observation before they entered your study. Okay, so that is some quick cap about what is left censoring. Okay, so usually like we are dealing with the right censoring or interval censoring or independent censoring. Okay, but for this throughout this course, we just focusing on right censoring type. Okay, and now we are going to look at functions which is available for survival analysis. Okay, so let us look at your lecture note, right? So not yesterday, last week, we have stopped until example 2 about the leukemia data, right? Where your data involve of an event and also a censoring data type, right? Now, today, we are going to focus on the survival function. Okay, survival and hazard function, right? So to that, right, so you can also refer to our official textbook, which is the textbook reference number 4. So this is actually the summarize of your of the function available also in your textbook. Okay, so I know that some of you never read the textbook, so I just want to explain in detail. So I just show to you the textbook. Okay, I will always use this textbook as a reference. Okay, right. So for a quick cap, we have looked at 2 examples, which is the hepatitis data and also the leukemia data, which is also available in your textbooks as well. Right, now we move on to this survivor hazard and cumulative hazard functions, right? So these are the common types of function in your survival analysis, okay? So number 1, we start with survival function. Okay, so just a moment, because I just want to use the pen, so I just can highlight something. So chapter 1. Okay. Missing that. Just close that bookmark, okay, because I just want everyone to see my screen. Okay, so we start with survival function. That's that one as well. Right, so the actual survival time of an individual T or patient T can be regarded as observed value of variable T. Okay, so as I said, when we want to analyze a survival data, it always involves time. Okay, because survival data is actually time to event data. right? So you need an event and also the time, right? So we represent the survival time as a capital T that can take any non-negative value. So the different values that T can take have a probability distribution, and we call T the random variable associated with survival time. Now, suppose that these random variables, right, has a probability distribution, okay? And I know this is a very common function, right? Ft. Um, this Ft equals to probability T less than T, which is equals to the integration from 0 to T Fu du, right? So this probability distribution function, okay, T, okay, is a survival time which is less than some value of your T, right? So this function, which is equation 1.1, is called the cumulative incident function, since it summarizes the cumulative probability of death, which is your event, before a time T, okay? So this is actually the end of the study period. So if you happen some events, then this is actually the cumulative probability of death, right? So we start with the Ft. What is this? Right. So again, right, because the reason I'm introduced to you the density function Ft is because the survival function St, okay, is equals to the probability of T greater than or equals to some value of T, which is equals to 1 minus Ft. Okay, so this is actually Ft, where Ft equals to uh, it's not really smooth, this handwriting. Okay, Ft equals to probability of T less than T, as I shown earlier, right? So St is equals to probability T greater than or equals to T, therefore it is equals to 1 minus Ft, right? Okay, so the survival function can therefore be used to represent the probability that an individual survived beyond any given T. Okay, so you survive after the event, right? So that is the survival function. Okay, so we represent the survival function as St. Right, any questions so far before we move on to the next function called the hazard function? Okay, so if you refer to your lecture notes, right? So in your lecture note, it doesn't explain about your FT, so it can be worthwhile. You can just write down some of the function of your FT, okay? Where your FT is actually, okay? So your FT is equals to um, the probability of T less than T, which is equals to the integration from 0 to T of your FUDU. Oh, I hate this. Okay, it's so stiff. I don't know. I don't know what's going on. Okay, right. So it's not that smooth. I don't know why. Okay, I think I need to update my my pen. Right. Sorry about that. Okay. Some of you might cause an anxiety due to my handwriting. Right. 0 to T of your FU. See, I missed this. FUDU. All right. So that is your FT. So your ST is equals to probability T greater than or equals to T, which is equals to 1 minus FT. Okay. Right. So I need to enlarge this. Okay. So, okay, so there are some notes here where the survival distribution usually skewed, so their location and dispersion can be expressed as the median and this percentile. So the median is actually S at T is at 50 percentile, which is equals to 0.5, and the P percentile is STP equals to 1 minus P. Okay? Any questions so far? Okay, so next we move on to the hazard function. Am I recording the session? Not yet. No. Okay. So someone has recorded to me. Is that okay if I just do it myself? Because if the student doing it, okay, it will stop in the middle. Okay, so I just stop the session.